Steam catapults waste energy as heat. Electromagnetic launch turns electricity into precision thrust. If the carrier war is about cycles, not size, what happens when your deck fires faster with less stress on the jets you need tomorrow?
Now, China's latest aircraft carrier, the Fujian, has successfully launched at least 3 types of aircraft using its new electromagnetic catapult system, also known as EMALS.
The EMALS system, it allows Fujian carrier aircraft to take off with heavier weapons and fuel loads compared to China's 2 older carriers, the Shandong and the Lining. The Fujian, which has set alarm bells ringing in the region and of course across the world. The aircraft is equipped with 3 advanced electromagnetic catapults, enabling the launch of carrier-based aircraft.
Now, stay with me. We'll break down how EMALS shapes sortie rate, why smoother acceleration preserves airframes, and how that shifts sustained combat math. By the end, you'll see why tonnage is a distraction and why the launch system is the real weapon. Before we move on, I'd like to ask you a small favor. If you appreciate this content, please take a second to like this video and subscribe to the channel. Over 98% of you watch the videos without subscribing. Costs you nothing, but it makes a huge difference to us. So, did you click the subscribe button? Great, thank you so much. Now back to the video.
Plane, they use a steam cannon that actually fires the plane off the end of the aircraft carrier, and that really is sort of taking the idea into its final and most modern form.
Principles explored by Ctesibius save military lives every day.
This is the front of the catapult. It's called the battery position. This is where the aircraft gets secured to the shuttle, which is attached to the rest of the catapult. It gives us the capability to accelerate aircraft weighing 55,000 pounds from 0 to 165 knots over a 300-foot distance in less than 2.5 seconds.
2 decks, same footprint, different heartbeat. The answer hides in the launch track, and you feel it in the tempo of aircraft cycling on and off the bow. EMALS is a linear electric motor. It turns stored electrical energy into controlled acceleration, pushing a shuttle with a magnetic field instead of a steam blast. Steam uses pressure and heat to yank a jet forward, venting waste with every shot. One system meters power like a dimmer switch. The other hits like a sledgehammer. Steam launches hard and fast, but that hit comes with cost. You burn energy you don't keep. You spike loads into the nose gear and airframe. EMALS promises smooth power and better control. But can it keep pace when the deck goes red? The wind shifts and salt creeps into every seam? That's the test that matters. Trace the energy path and the logic clicks. Steam starts in boilers, drives pistons, pushes a shuttle down a track, then dumps heat and vapor into the air. Every link leaks efficiency. EMALS taps an integrated power system, shunts energy into storage, flywheels, capacitors, and releases it through a linear induction motor, with software that shapes the force along the stroke so the jet gets exactly the push it needs, no more, no less. Think runway dynamics. Steam is a car yanked by a jerky rope. The nose snaps, the frame rattles, and you get to speed by brute force. EMALS is an electric rail pulling clean and even. Same end speed, but fewer spikes.
System, it allows for sustained operations far from home waters, providing the Fujian with blue water capabilities, thus increasing the aircraft operational range and effectiveness. Now, this technological breakthrough, it enables Fujian's aircraft to strike enemy targets from greater distances.
That drop in peak load matters. It's kinder to the nose gear. It eases the fatigue that creeps into wings and joints across hundreds of cycles. Research and tests point to a simple effect. Smoother acceleration reduces stress. Lower stress means you can launch aircraft at higher gross weights without chewing up margins. That opens room for more fuel, heavier stores, and more delicate platforms. Unmanned aircraft with lighter landing gear benefit from the shaped push. So do strike jets loaded for range, not show. Now look at tempo. Steam needs venting and heat control. That means more crew work between shots, more time handling hotlines, and a rhythm set by thermal overhead. EMALS doesn't vent steam, and it can reset fast once the storage banks are back in the green.
Gets the end of the power stroke, the aircraft is permitted to continue flying. Within the launching engine are power cylinders that run the full length of the catapult. Within the cylinders are pistons that are linked to the shuttle, which are next to the aircraft. When you're ready to fire the catapult, it's a programmed opening of the launch valve, which admits steam into the cylinders.
Add programmable launch profiles, and the crew runs a tighter sequence across dissimilar aircraft without chasing mechanical tweaks between each cat shot. Control is the quiet edge. MIGHTY aims for finer end speed control and tighter tolerance than legacy steam. That precision broadens the launch envelope. Heavier, lighter, fragile, high drag. Profiles can be dialed in software rather than fought in hardware. You don't claim magic. You claim repeatability. That's what wins long fights. What does that look like under pressure? Deckhands stage jets in tighter stacks because the launch profile is predictable. Pilots get a smoother throw, which cuts down on post-launch checks for shock-induced warnings. Maintainers see fewer nose strut issues and less hidden fatigue that steals availability later in the cruise. Each small gain adds up to more cycles per hour when the air wing is surging. The payoff is clearest over days, not minutes. Steam gives you a punchy morning. MIGHTY keeps the cadence through the evening sortie. Then again the next dawn. The energy the ship generates stays in the electrical ecosystem, stored, managed, and metered out, rather than blown off the bow as heat. That's logistics translated into launches. Fuijan leans into that logic. Its MIGHTY is built as a tempo machine, not a showpiece. 3 tracks fed by integrated power and storage raise the ceiling on what gets off the deck, how often, and how intact those jets come back to do it again. The air wing becomes a metronome. You don't chase numbers, you enforce rhythm. If launch is cleaner and faster, the real metric isn't tonnage at all. It's sustained sortie rate under pressure. That's where a carrier wins the week, not just the morning. And once you think in weeks, you stop asking who looks bigger at anchor and start asking who can keep feeding the fight without tearing itself apart. The weapon isn't the hull, it's the cadence. MIGHTY turns raw electrical power into repeatable aircraft-friendly throws that keep the air wing on the clock. Fewer shocks, cleaner cycles, more jets ready when it counts. You feel that edge by the 3rd day of hard ops. Less hidden fatigue, fewer nose gear bites, launch profiles set in software, not wrenches. That's sustained output, not a one-time flex. Comment your choice below, tempo or tonnage. And if you want more hard-nosed analysis on the systems that decide wars at sea, subscribe. The Fuijan's edge lives in the rail. If cycles measure the next duel, watch this tech.